It's D. Why?
Because it's multiplying, which means that it works.
Yeah, but she spent a third.
And
That's 2/3.
spending a third means when you multiply it, it's taking the number. When you spend your third, you take 1/3 out.
Yeah.
And multiplying it.
So what you're saying is when you spend a third, it leaves you with 2/3, which would be our decay factor.
Yeah.
Awesome. Thanks, Will. That was a great explanation. So next up, this says using graphing technology, but you guys already know enough. You guys already know that a function has an initial value and a growth factor, right? Everybody go with that? So what I want you to do is, like, say what you know must be different about these in terms of their graph. Like, if you were to look at their graphs, what would be different about them and what would be the same? So I'm looking for different and same. So it's in the same vein as these questions. I just think you know enough. We don't need to put them in decimals. So I'm going to give you 2 minutes with your table partner. Let's go with what's the same. If we saw these on a graph, I think we've seen enough graphs that we don't have to do this. What would be true? Like, what would be the same about all the graphs, Micah?
The y-intercept.
Yeah.
All start at 50.
Yeah, starting point is 50, right? For all of them. Or, as some people say, 50. Okay? Now, what's different about them? How would I describe their differences, and how would it look on a graph, Hadley?
They have different growth factors.
Yeah, so I want to say growth / decay
They have different factors.
are different. So which one, how could you, like, what would it look like to have, like, a greater growth factor?
It would like start approaching infinity way faster.
Yeah, approaching infinity, so it's like steeper might be a way we'd see it, right? So looking at these, which one would be the steepest, do you think? G of x would be steepest, then what? F of x, then what? And then what's special about this last one that's quite different than the rest, Will?
It's a negative. And in terms of decay.
This is the only decay factor, right? Notice, did we ever multiply by a negative once ever in this unit? No. So to multiply and get a number that's smaller, we just need to multiply by a number that is smaller than 1. So all these have a growth factor greater than 1. This decay factor because it's less than 1. Now we could compare decay factors by what would be steeper, or what would, I like how Hadley said, approach infinity quicker. For decay it'd be approach 0 quicker. So we have these comparisons we can make. Yeah, Raymer?
Wouldn't on 3 and 4 be the same, not
Steepness?
like steep,
Yeah, so a 1.5 and a 0.5, a 50% increase and a 50% decrease. Yeah, steepness, but it looked different. One would be growth, one would be decay. I like how you're thinking about that. Okay, so everybody's good on this? We don't need to look at the decimals, I think. I think we've seen enough. We're going to save a little time there. So what you're going to do next is you're going to look at these and say what is the same, kind of the same thing. What's the same? What's different? What would that look like on a graph? I like to think of it as same and different myself. 1 minute with your table partner. So, what is the same about all these? Who can tell me, like, looking at these about the graph, Finn, what would we know is all the same? Yeah, same growth, right? They all have a growth factor of 4. So in terms of steepness, samesies. So what's going to be different about these graphs, Grant? The y-intercept. So they have different starting points. You guys think these will ever touch or cross each other? Never. Same. Yep, same different starting points, but then they're going to all grow at the same difference then. Cool. We need to see a graph where we can imagine it well. I feel like we've seen enough of these where we're feeling it. Next, you're going to match these 4 functions here. You're going to match them with the correct function over here. And then you're going to explain which one is decaying more quickly for number 2. I'm going to give you 3 minutes with your partner. Oh, and give me one of them.
Q is A.
So Q of X you think is A? All right, let's see here. Why do you think it's A?
Because it's decreasingly slower.
So these are all decay factors. This one's only losing an 1/8.
Yes.
Quick. Who's got another one for me? Emmett.
D is M.
D is M, you're saying. Let's take a look.
Okay, fastest.
So there's the least left, so it's going to approach 0 the quickest. Okay, I see that. Hadley,
N is C.
how do you know that one? So it's got to be steeper. It's got to be between A and D, but it's got to be it's the steeper one of the two. Is kind of what you're saying, okay? So Tess, what's the last one got to be? What's the last one got to be? What? You trying to do a pun? What's the last one got to be?
B.
Yeah, that's what I said.
Yeah.
Oh, okay. The last one's got to be B. It's a little less than A, but it's also kind of in between. This reminds me of the game. These colors remind me of the game that Simon Says game thing.
Oh yeah. Like
Simon, just Simon? Okay, yeah. All right, for number 2. Which one is decaying more quickly and how do you know? Elliot.
I think f of x decaying more quickly.
But 1/10 is less than 9/10.
1/10 is how much of the like down.
Yeah. So less left. There's less left. So it's going to decay quicker. Approach, like I said, I like how Hallie said earlier, kind of. Approach 0 more quickly. All right. I'm stealing Hallie's stuff. I steal stuff I like. How do you think I got this Rolex?
You got it from Goodwill.
No, not a Rolex. I actually don't steal it. I just steal ideas, not things. But I actually don't steal anything. It's legal if it's for education. All right. So we've got a quick little summary. Summary is not going to be the gatekeeper today to homework. We are going to do a cool down in a moment that is the gatekeeper. So do the summary in 2 minutes and we're going to give you the cool down. Okay, let's take a look at this. So what's the difference in my two functions? The growth, right? So one's doubling, one's 20% more. And we know that this one's 1.5, right? So if this one is the 1.5, which one is steeper? This one's steeper. And which one's less steep? R. Cool? It's all about comparing today. Okay. Can we describe the effect of changing on a graph? Yes. Can we use equations to compare? Yes. Here is your cool down. You will show this to me to gain access to your homework. When you're done with your homework, the review's in the top basket.